Hello there, this is Mrs. Nakayama, and today's lesson starts our chapter 6, which is called Additional Topics in Trigonometry. The first lesson we're going to go over today is 6.1, the Law of Sines. I believe you covered this in Geometry and Algebra 2, but we have one extra case that we have to talk about this year. So in this video, I'm going to cover solving oblique triangles, what it means to solve a triangle, especially those that are oblique. I'm going to talk about the ambiguous case. I'm going to find the area of oblique triangles, and we're going to solve applied problems using the law of sines. So first and foremost, let's make sure everybody knows what an oblique triangle. Oblique triangle is one that does not contain a right angle. So it either has 3 acute angles, or it has 2 acute angles and an obtuse angle. More importantly, because it does not have a right angle, you've got to remember that you cannot use SOHCAHTOA at all in these problems. Okay, so this first one that we have is the law of sines, and it tells you that the ratio of a side and the sine of the angle opposite. Okay, remember that little a are side, little letters are the sides, and capital letters are the angles opposite those sides. Okay, so we already know that from SOHCAHTOA. But so the ratio of a side and the sine of the angle opposite is the same for every part of the triangle, and we are going to use that to solve oblique triangles. Now, one other thing I want to tell you, this is the main law of sines, but remember that we can flip any ratio. If I know that 2/3 is equal to 4/6, y'all know that, well, that means I can flip both sides and say that 3/2 is equal to 6/4. So I'm telling you that because I'm going to set up these problems so that they're the easiest way to solve them, so that you can solve them in one step. Okay, that doesn't mean that's how you have to do it. I'm just trying to make it the easiest for you. Okay, so in solving an oblique triangle, they put a lot of attention on whether or not you know AAS or ASA. I don't worry about that. It will always work if you just know if I have a pair, and when I say pair, that means a side and angle that are opposite each other. If I know a pair, I can use the law of sines. So let's look at our first example. So solve the triangle with A equal to 64 degrees, C equals 82 degrees, and little c equals 14. Round the lengths of the sides to the nearest tenth. Okay, so if I'm solving, that means that I have to find big B, because I don't know that angle. I have to find little a, and I have to find little b. And once I do that, then I will have finished the problem. I got to find all 3 of those things. So first and foremost, if you know two angles of a triangle, you know the third, because all 3 angles have to add up to 180. So my first one, 64 plus 82 plus angle B is got to equal 180, which means that B is 34. So that was an easy one, and I label it on my picture. Okay, now the next thing I'm going to do is set up that extended proportion with my law of sines. And so the order that you do these in doesn't matter. I just normally do A, B, C. So I'm looking for little a, and I have the sine of 64 because that's the opposite. That's big A. And then I have little b and the sine of 34. And then I have little c, which we know is 14. I was worried that was going to happen. Then we have little c, which is 14, over the sine of c, which is 82. Okay, so that's my extended proportion. And you have to use the proportion where you only have one variable. So which of these do I only have one variable are the one on the right, this part right here. I only have a variable. I'm only looking for b. So when I set this up, again, I always set up what I'm looking for to be on top, because then all I have to do is get rid of this sine of 34, and you're always going to multiply. So an easier way I like to do is I'm just going to move it over there. So that means that b equals 14 times the sine of 34 over the sine of 82. We are in degrees. Put it in your calculator, and you get 7.906. Now, if we are rounding our answers, y'all, to the nearest tenth, okay, that means the answer that I'm going to put in my answer box is going to be 7.9 centimeters, but I have to carry 7.906 through the problem. So now that I know that, I'm going to go back to my extended proportion, and this time I'm going to use this part of it. And I'm going to fill in, I already knew A, sine of 64, and the sine of 34, but for B, I need to put 7.906. Okay, so you will miss it. You can put 7.91, but if you put 7.9, then you're going to mess up your rounding, and your answer is going to get counted wrong in MyLab Math. So you don't ever round to the 10th until the very end, and you put your answer in. All right, so I multiply by the sine of 64, which means it's going to move over there, and I write it. So A equals, I always write it like that with the number in front of the sign so that there's no confusion. And if you put it in your calculator just like that, you won't forget to close the parentheses when you're trying to find the sine of the angle. So punch that in, which you should be doing to make sure you know how to do things, and you get 12.707, which means my final answer is going to be 12.7 centimeters. All right, that is the first example. Let's look at this next one. All right, it is a little bit different. Still, we have a triangle ABC. If A is 40 and C is 22.5 and little b is 12. All right, I've got to find, what do I have to find? I've got to find the angle B, and I have to find little a and little c. And when I find all those, then I will have all my answers. So, first and foremost, that angle. So if I know two angles, I can always find the third. So I have 40, or is it? Neat. Well, that wasn't what I was looking for. There it is. 40 plus 22.5 plus b equals 180. So b is equal to 117.5. Round measures to the nearest tenth. So I'm going to put 117.5 degrees in my answer in MyLab Math. Now I'm going to go write my extended proportion. In my extended proportion, I'm going to have a, I don't know what a is, a over the sine of 40. And then I'm going to have b, but b is 12 this time, over the sine of b. And then I'm going to have c over the sine of 22.5. Okay? Now, the order that you do these in does not matter. I'm just going from left to right, but I'm going to find a proportion. I only have one variable, and so that would be these first two ratios right here. That's not, I jumped the gun. Go away. I didn't mean to do that. Thank you. All right, so I'm going to use this proportion right here. And if I'm solving for A, I'm going to multiply by the sine of 40, which means I just have to move that guy over there. And so A equals 12 times the sine of 40 divided by 117.5. Punch that in your calculator and you get 8.696. So my answer in MyLab Math is going to be 8.7. Okay? And now I'm going to go back and use the other side. So the other side of this is going to, I have 12 over sine of 117.5 equals c over 22.5. So I need to get rid of the sine of 22.5. And so it looks like that. 12 times the sine of 22.5 divided by the sine of 117.5 equals c. And so c equals 5.177, which of course is 5.2. I hope y'all pay attention and know there is always something. I mean, if you want to just write this step right here, that's fine. I don't advise it. There's a lot of work to do. You're skipping steps, but this would be the minimum thing that I would expect to see on your paper. Okay? All right. So this is the new situation. We have something called the ambiguous case, and what you need to know is whenever you're looking for an angle. All right, these two problems we just did, what we were looking for were sides because we figured out We were given two angles, and we just had to find the third by adding up to 180. Well, now we're only going to be given one angle and two sides. And so these are the different possibilities. You can either, if it's acute, you can have no solution, one solution, or two solutions. And if it's obtuse, then you can have no solution or one solution. But I'm going to tell you, when you do it, if you're always looking for the angle first, then you need to think of two cases. So look at these examples. My first one, I have triangle ABC. A is 50 degrees, little a is 10, and little b is 20. Round the lengths of the sides to the nearest tenth and angles to the nearest degree. So, because I'm only given one angle and two sides, then I'm going to know I got to think about the possibility of two triangles. Okay? I've got to find big B, I got to find big C, and I got to find little c. So, I'm going to set up my extended proportion, and I'm going to have, now remember, I'm going for an angle first, and because I'm going for an angle, I told y'all earlier in the video, I'm going to switch, I'm going to flip my proportion, and I'm going to put the angles on top. Makes it easier to solve. So the sine of 50 over 10, because the a's go together, equals the sine of b over 20 equals the sine of c over little c. So clearly the one where only has one variable is this proportion right here. To solve it, I'm going to multiply both sides by 20, which is going to move that guy right in front. So it's going to say 20 times the sine of 50 divided by 10 equals the sine of b. Okay? Excuse me. I like to write this next step because it helps people remember. This is the button that you use on your calculator to find the angle. So when you do that, most of your calculator is going to say domain error. And we just talked about this while we reviewed for the test. Okay? So if you have this issue, what I would encourage you to do would be to go put this in your calculator to make sure you've done it correctly. And if that number is more than 1, it makes sense I have a domain error, because we talked about the sine of an angle and the cosine of an angle can't be larger than 1. So in this particular case, no triangle is possible. So you need to be aware of that. All right, look at this one. Solve a triangle ABC if A is 35, B is 12, and little a is 12 and little b is 16. And then rounding sides to the 10th and angles to the degree. So again, I've given one angle. If I'm given one angle, the first thing I'm going to find is an angle, which means I need to think of the possibility of two triangles. So I'm going to set up a chart. Triangle 1, triangle 2. I'm looking for big B, big C, and little c. So I'm going to set up my proportion. I'm going to have the sine of A, which is sine of 35 over little a is 12. The sine of B over little b, which is 16. The sine of C over C. Okay? This first proportion, two ratios equal to each other, is a proportion. Okay? So that proportion, I only have one variable, and that's B. So I'm going to multiply both sides by 16, which moves that 16 up there. And the sine of B is equal to 16 times the sine of 35 divided by 12. So B is equal to the inverse sine of that mess. And B is equal to 49.89. So if you haven't learned anything in Chapter 5, you should know that there's more than one angle that has that sine value. So you know that B is equal to 50, but remember that the sine is positive in two quadrants. So this angle is 50 and that angle is 50. So this angle is 50 and the other angle, I know, is 130 because it's 50 before 180. So I'm going to go fill in those two things right there. I don't know why that happened. All right, so B is 50 or 30. I find the first one using my extended proportion, and the second one you always find by subtracting from 180. Okay? Now, from this point, y'all, to keep your information straight, we're going to ignore this. Okay? and we're going to solve just the first triangle. So in solving just that first triangle, if I know that A is 35 and B is 50, then I know that all three of those have to add up to 180, and so that means that C is 95. And now I can go fill in that proportion. So this is what I'm going to have. The sine, oh, but guess what? I'm looking for a side now. And because I'm looking for a side, I'm going to flip it back and make the side on top. So I'm going to make it 12 over the sine of 35 equals C sub 1. I put C sub 1 because it's the first triangle, over the sine of C, which was 95 in our case. So I solve by multiplying both sides by sine of 95. So C sub 1 equals 12 times the sine of 95 over the sine of 35, and C sub 1 equals 20.84. I'm rounding sides to the nearest tenth, so that makes it 20.8. Okay? So now that I've solved the first triangle, y'all. I'm now going to go solve the second triangle, and I'm going to ignore all this. Okay? So basically, I'm using this exact same thing. Okay? But watch. I still have 12 over the sine of 35. But this time I have C sub 2. And what's opposite is not, we didn't finish this. We don't know what that angle is. What is that angle? Well, I've got an angle that's 35 and I've got an angle that's 130. And those three angles have to add up to 180. So that makes the other angle 15. And so that's what's going to be under here is the sine of 15. Multiply both sides by that sine of 15. So C sub 2 equals 12 times the sine of 15 over the sine of 35. Punch it in your calculator, and you get 5.41. So that's 5.4. And that is what our answers look like. Okay? So you might bookmark this to listen to this explanation again, because it can be confusing for people. All right, two more quick things. One is the area of an oblique triangle. Okay? The area is basically right here for you. However you wish. It's 1/2 the product of two sides and the sine of the included angle. So that can be written 1/2 BC times the sine of A, 1/2 AB times the sine of C, 1/2 AC times the sine of B. It does not matter which one you use. This one is what I see most often. So that's the one that's just kind of ingrained in my memory, but it does not matter which one you use. You just got to know two sides and the angle in between them. So look at this first example. Find the area of a triangle having two sides of length 8 meters and 12 meters and an included angle of 135 degrees. Round to the nearest square meter. I think I didn't know what just happened. Sorry. All right, so back to area is, as I said, I like the one in the middle, 1/2 AB times the sine of C. Then I'm going to go plug in for A, B, and C. A, it does not, well, A is, you know what, it doesn't really matter, but A should be 12, but I put it as 8 because the multiplication doesn't matter. But I should have put 12 first and then 8 times the sine of 135. But really what I'm remembering, I'm looking at this picture. And if I have two sides and the angle in between them, the area is 1/2 this times the sine of that. Put that in your calculator. You get 33.94. Rounded to the nearest square meter is 34 square meters. All right, last problem. All right. Two fire lookout stations are 13 miles apart with station B directly east of station A. Okay, got to know which way is east. B is east of A, 13 miles. Both stations spot a fire. There's the fire. The bearing of the fire from station A. So here's station A. And y'all remember that when you have bearing, you always measure from the north. So that bearing is 35 degrees east of north. That means this is the angle that's 35 degrees. And the bearing of the fire from station B is 49 degrees west of north. So that angle is 49 degrees. Okay? So you can find the two angles between them, okay? Or you can find the angles in our triangle are not 35 and 49. All right, this is 35, so what's that angle have to be? Together, I didn't do that. Together, they make 90 degrees. So 90 minus 35 is 55, and 90 minus 49 is 41. The question says, and actually before I even go to that question, I'm going to go ahead and find what's that top angle. Okay, that top angle, they all have to add up to 180, so 55 plus 41 subtracted from 180 leaves me with 84. The question says, how far to the nearest tenth of a mile is the fire from station B? So they're asking me for this right here, which in my little triangle means is little a. So you can write the extended proportion if you want, but I do have a pair. Okay, so my proportion, I'm looking for little a, so I'm going to put that on top. Makes it easiest to solve. And the opposite a is 55, so a over the sine of 55 equals, the pair that I have is 13. Okay, 13 over the sine of 84 because it's opposite. Okay, to solve, all I have to do is multiply by that bottom number, which moves it over to the other side. So a equals 13 times the sine of 55 over the sine of 84, and a equals 10.7076, rounded to the nearest tenth of a mile, is 10.7 miles. So you have two formulas, the law of sines and the area of a triangle. If you will write them down every time you do a practice problem, you'll have it memorized and it will be easy to take your lesson check. Thank you so much for watching, and y'all have a great day. Please don't hesitate to come see me if you have any questions.